Hello and welcome to this StrongLearn series of videos looking at tree diagrams. And in this first session we are going to look at calculating probabilities associated with mutually exclusive events. So we need to really start with tackling what that term mutually exclusive means. Now mutually exclusive means that the events cannot happen at the same time. So for instance, let me give you an example of something which is not mutually exclusive first. So for instance, let's imagine we rolled 2 die. No, let's not think about 2 die, let's just think about the single die actually. So if we roll a single die, let's think about the outcome that we get an even number and the outcome that we get a prime number. So are those two things mutually exclusive? Well, they're not mutually exclusive, because if I was to roll a 2, that's both a prime number and an even number, and therefore it is possible that those two things can happen together. If, for instance, though, I said what was the probability of an even number and a multiple of 5, now they are mutually exclusive, because if we think about a normal dice, the possible even numbers are 2, 4 and 6. The possible multiples of 5 are 5, and there's no overlap there. So that would be an example of mutually exclusive events. So there is some really handy things or properties of this which allows us to work things out. And the key one is that the sum of mutually exclusive outcomes is 1. 1 being the probability we use for certainty. So this first example is a relatively straightforward one. We're looking at a seed and we know the probability it germinates is 0.07. So what's the probability it does not germinate? Okay, so those two things are mutually exclusive. If it's germinated, then it hasn't not germinated. So the sum of probabilities is 1. So if I subtract the one I know about, I'm left with 0.93, and there we go. Now this next one is a much more challenging question. So we've got a netball team that can win, lose or draw. So we've got 3 options. They are mutually exclusive again, because if you won, you haven't lost or drawn, and we can deduce the same if we think about loss or draw. So the team are predicted to win 4 games for every 5 they lose. The probability the team draws a match is 1/10. Find the probability the team wins a match. Okay, so there's a few different ways that you can think about this. If we want to go for kind of a reliable method, let's think about ratios. So we've got win, we've got draw, and we've got loss. And we know for every 4 they win, they lose 5. Okay, I don't know about the draw. I might just call that X because I don't know what it is, and we tend to go for X when we don't know what something is. Okay, so we've got that information, and we know the probability the team draws is 1/10. So 1/10 is our probability of drawing, and if we use our ratio, we can see that there's X draws, and then there's 4 plus X plus 5 games in total. So that's looking at a fraction of draws of the total games, and that's going to be the same as the probability. So if we simplify this, we get 1/10 equals X over X plus 9. Maybe what we want to do now is multiply both sides of this by 10. And then maybe multiply both sides by X plus 9. So over here, which leaves me with X plus 9 equals 10X. And subtract X from both sides. 9 equals 9X. Divide by 9. 1 equals X. And if the probability of drawing was 1/10, yeah, we started at the beginning, and we've got the X as 1, so we can now put in our ratio 4 to 1 to 5, and then we can see the probability of winning 4 wins out of 10 matches, because 10 is now the 4 plus 1 plus the 5. Okay, so there we go, we have answered that question. Now, doing a little bit of kind of trial and error or trial and improvement may get you the answer in a quicker way, but there's a method that would work for any problem such as this. So two sets of questions to have a look at here. First set is just about deciding whether or not two events are mutually exclusive or not. So just to remember, think about the two events. Can they both happen at the same time? If the answer to that question is no, then they are mutually exclusive. And if the answer to that question is yes, then they are not mutually exclusive. The set B questions, you are trying to find the probability that it's asked for using the fact that we know the sum of mutually exclusive events is 1. Some of them are straightforward, some of them are quite tough. And here are the answers.